Yeah, it's my pleasure, my privilege, my honour to close out today in the graveyard shift, talk to you about sleepers. So as part of one of my other sins, I chair our sleeper strategy group for Network Rail. And as part of that, that covers composite, low carbon concrete and so on. And I'm going to run you through some of the targets that we're looking at the moment and where where the land lies in that domain at the moment. So open it up with a slide I always like to use, which is about what's driving the change. We've heard a lot already today, and it conveniently coincides with my presentation as well around increased asset life. We had a regulatory ban back in 2021 around the use of creosote, which prompted the change specifically for softwoods in the first instance and is now rolling out across timber. We've spoken a lot as well today about carbon and sustainability and circularity. That's obviously a big target the Network Rail is striving for, and one of the big targets on our environmental strategy as well is to improve that sustainability and ultimately reduce whole life cost where we can as well. So we're looking at all of those elements as we talk about composites and indeed low carbon. So in terms of carbon dioxide in particular, we've talked a lot about this and how much of an impact we as TRAC have in that space. What we look at across the board is the different sleeper types, and between 2023 and 2022 and 25, these are the sort of targets that we're aspiring to achieve in the sleeper world. So a significant reduction in the carbon dioxide or the carbon content in concrete sleepers. These values are a little out of date actually. The one on the left-hand side here, we're probably closer to around 50 now. The plastic sleepers that we're introducing are where they are, which is already very low, which we're happy to see. We have an alternate project on integrated composite sleepers, which we will cover, I'll briefly cover later on. And we're looking at introducing these sulfur alternative sleepers, which I'll also cover. Steel, I won't be covering in much detail in this presentation specifically because we're focusing on composites and low carbon, but that is part of the target. It's a bit more of a longer term strategy and looking at the alternative options that we have in there. But again, another massive opportunity to reduce the CO2 in that space as well. And when you look at that in terms of annual savings of carbon dioxide, it's looking at sort of like a 50% reduction across the sleeper category, which is pretty significant, I'd say. Gareth has already spoken a lot about product approval. I won't bore people to tears on why it's a difficult process and a long-winded one, but a prime example of why it's necessary, I think, is in the composite sleeper space where we went through all of the processes for the right reasons, I think. Significant input is required in it, and that's what takes a lot of time. So for the composite sleeper example, it's a 40-page document that goes into the design for reliability. The common safety method is analysing 100 or so risks which are outside of our existing understanding of how we operate with current sleepers, and we have to close each one of those out. Then we've got to understand what we're missing, what we don't understand to fill in those trials. We have to control that at a national level as well. We've spoken a lot about how regional differences will occur. We need to manage that on a case by case, but if we're rolling this out nationally, it has to be fit for purpose for everyone. So it does take time. I know it takes time, but it's for the right reasons. And I'll show you why slightly later on. HDPE, people are probably fairly familiar with this now. I think it's probably come really into the forefront in the last year or so. We've been using them since about 2021 when that creosote ban came in, and that was really the instigator for pushing towards composites as well as the sustainability argument. We have a contract with SICA at the moment, which is running, and we have two products that are approved. It's 135mm depth and a 155. The 135 was originally the replacement for the softwood, and that goes up to about Cat 2 on the product approval now. And we're looking at the 155 as an alternative to Cat 1 and potentially Cat 1A. We've got trials about to be underway with 110 mile an hour line speed for that. So it's pushing up towards the realms of where we can fit it into either concrete or higher speed running, and where we can place hardwoods in specific track forms. But yeah, so it's suitable for plain line, obviously, ballasted applications. That's where the tender comes in. It's got different failure modes to wood, which we have to understand, and obviously those operating, maintaining the track, you have to understand what those differences are, so you know what you're looking for when it does come to failure. And the only real caveat is around screw spikes. So we use screw spikes in plastic, not rail spikes. That does cause some problems, and I know we're having a lot of conversations about that at the moment, especially around things like BR1 base plates. That's another angle we have to go to, but there are specific failure modes that we have recognised in plastics and HDPE, which is pushing the change to move away from spikes with composites. We're going through the finalising of the approvals for high output as well, and the automated track relaying machines as well, and that ties into HDPE, so hopefully that will then become another tool in the arsenal for higher speed renewals. I mentioned all the stuff we did on product approval, but that doesn't necessarily catch everything. We try and catch as much as we can, but we do still have some issues, and I think it's worth sharing some of those issues and the previous concerns we have, and sort of put some of those to bed, I think, because we've done a lot of work in that space to try and close these out. That was a big thing about fire risk when we first introduced them. Can we use them in tunnels? Can we not? We've had a lot of conversations with our fire engineers in the technical authority, trying to understand what fire requirements are required. People say HDPE and everyone screams Grenfell, for obvious reasons and understandable, but we need to understand what you actually need from a component in HDPE, where that risk is, and actually is it a risk to us from a track perspective. We did a whole load of testing. You can see some of the examples of the testing on the slides there. And overall, you come out with some categorization. Generally, we say it's, I won't bore you with the details of the testing itself, but we say it's basically better than timber in almost all of the aspects, although some are on par with timber. In terms of fire risk and use in tunnels, we did get approval from the fire engineers to use that, and subsequently that was one of the positives that came out of all the testing that we did. There is something of a hierarchy, obviously preference to use concrete because it is higher performing in tunnels, but we know that's not appropriate for everywhere. That's where composites come in above timber. FFU falls into this camp as well, so it does have a slightly higher classification than HDPE does. I'll go on to FFU. I know we've touched on it slightly earlier on, but there's some other conversations and some other areas to delve into on that one, and FFU isn't currently approved as a sleeper type or fully at this stage. It's all HDPE. Thermal coefficient of expansion was another one. Plastic moves more than concretes do, or also moves more than woods do. There are some conversations ongoing about how much of this we can tolerate. From a plane line perspective, we're quite comfortable where it is. The relative gauge change, especially once it's actually in track and embedded around ballast, is relatively small. Although there is some conversation still ongoing about what happens in sort of free and open air when you're fixing down and you gauge in the morning, gauge in the afternoon when you're setting out of panels. That's still an open question, but I think we're quite confident, definitely in the plane line space. Some more conversations to go on in S&C, which we're not quite there yet, but we've bottomed out that some of the issues that we did have early on weren't really to do with thermal coefficient of expansion, but more around plating up. Into FFU, we should know the definition of FFU now. So we've been through it earlier on, so I won't harp on, but we do use it in longitudinal bearer systems. They've first been in use in the UK from 2014, which is when we first approved them. We fully approved them in 2021 after a number of trials, mainly on Southern. And Sekisui hold that contract for us at the moment. That does cover bridge sleepers, and we do have the infamous Newark flat crossing in FFU as well, which has seen a lot of press across Network Rail in particular and the public domain as well, so hopefully people are aware of that. Some of the more common questions I get on FFU, bridge sleepers, yes, it's fine for use in bridge sleepers. In and around transitions, if you're coming on and off longitudinal bearer systems, it's a good place for it to be as well, especially if you can manage some of the stiffness if you're going into some stiffer track forms or on and off. It's suitable for direct fixing as well. Ballasted bridges is still okay as well, still covered under the bridge sleepers, obviously. And all of that should, whilst it can be used, it should obviously all be designed within the longitudinal bearer system or the bridge system itself. So whilst it is suitable for use, you have to make sure it's fit for purpose for where you're using it. And one question I got more recently was the cross-use with HDPE. So can you run longitudinal bearers and then use cross sleepers over the top of it in HDPE? And at the moment, that's a no, just because we don't know what limitations there are between the two stiffnesses. HDPE and FFU perform very differently dynamically, and we haven't really evaluated that in enough detail yet to be able to say, yes, they can safely be used together. We've got some cases where we've got different stiffnesses of materials, and that's resulted in some loosening of bolts and stuff, so a genuine risk we want to manage separately. We are moving into the space of sleepers with FFU. So in 2021, we started some of the approval methods. We've got some good experience from Japan in this space, where they've been using them on Shinkansen for a long time. And so we're quite confident that actually use in high speed is going to be less of a problem than maybe HDPE, because we have a lot less information on HDPE. But what we're balancing now is the contractual element that we have with HDPE in the SICOT contract and the introduction of FFU. So going back to some of the procurement issues, I think, that were mentioned earlier by Gareth as well. We're kind of balancing that out at the moment. At the moment, we're running this through a trial program so that we have FFU available for when we get to the next contracting point. So we have a small section for approval. There's no free issue of it at the moment, but the installations that we do have are looking quite promising so far. We don't have any real actual data to present at this point in time, but it's another step in the positive direction, I think. Another question that came through is alternative uses, so where we do have wooden assets, where we maybe want to replace those and look at alternatives. Are there places where we can do this? Can we put something in that's a little bit longer life, a little bit more reliable? And this is one of the alternative uses that came out of that. So we've got a couple of trials running on Southern at the moment for using them in place of timber level crossings. So we've done some modifications to try and get them up to scratch. So instead of just doing a like for like with timber, try and improve it, move towards the 4040 level crossing standards. So putting some etching, you can see this bottom left, if the pointer works, there we go. Some sort of etching on the surface to try and do some non-slip work in accordance with the standard, try and meet the individual loading requirements. It's never going to replace the fully fledged sort of strail systems that we know and see everywhere. But they can still serve a purpose in replacing timber, and we just need to find where that is at the moment. So those trials are ongoing. The FFU is looking quite strong in that aspect. There's some design considerations we still need to explore. But as an alternative to timber, it's still looking very positive. There is some issue around some calculations. So I did mention not replacing of strail. So for this case in particular, for using it as an alternative to level crossings, we have to move to the guaranteed value for the Sekisui product to the guaranteed value, not necessarily a calculation value. So we have to derogate to enable to get the upper limit of what we're allowed in terms of loading requirements in accordance with the 4040 standard. So when I say there's some tweaking to do, it's never going to go into primary roads to replace the strail system, but it could be used as an alternative for some of the lower used crossings, farm crossings and the like. We have some control framework, which I hope some of you might be aware of already. If you don't, or if you aren't, then hopefully this will shed some light. So we have the 039 standard, which came out December last year. That covers the technical requirements for our sleepers and our sleeper suppliers to manufacture in accordance to. So that sets out some of our gauging requirements, the fire requirements, and the requirements the suppliers have in order to supply to us. From a maintenance perspective, we have two TWIs at the moment. There's the 3C039 and 040. Both of those published last year as well, and that covers the SciCut product and the FFU product in their respective terms at the moment. So the SciCut product for plain-line sleepers, the FFU product predominantly for longitudinal bearer systems. But inside those documents, you'll find a lot of the stuff about failure modes, inspection, maintenance, replacement requirements. So should give some good information. And I'd say go and have a look into them if you're looking at maintaining any of those products, because I think they're quite valuable resources. Following on from some of the conversation about CO2, 039 was quite a groundbreaking, I suppose, stand in the sense of it was one of the first we put in sustainability and eco-design requirements for our product suppliers, and it will be something that carries through into some of our alternative products as well, as and when those standards get updated. Specifically looking at the organic pollutants, no pointer, but anyway, right at the bottom, and the EPD. So getting our suppliers to lay out exactly where all of the materials come from, cradle to effectively ex-works and onwards, to basically tell us exactly how that carbon is produced, and so that we have an accurate record. Instead of relying on them to give us a CO2 figure, they have to demonstrate from start to finish their values, and we can audit that as well. I did cover off 039 and 040. There's some key messages out of there which I think are probably worth sharing. Predominantly FFU is very similar to wood. Its failure modes are very similar, other than it will shear rather than split like traditional wood will, and that's what you see in this picture here. It's generally cut at slow speed so you don't melt the material, and you've got specific paints and quick fillers to use in place of spike fast. And then when cutting or drilling, using masks and goggles is recommended, and a vacuum if you've got it to hand. For SciCut, the main failure modes, or HCP in general, bending, warping, plastic deformation, some base plate indentation in some cases, and material cracking. They're generally placed off-site. You can see from some of the images on the right-hand side. If you drill them yourself, well, we drill them generally off-site because firstly, it's easier, but secondly, if the counterbore is not put into place, you can end up with this sort of lifted base plate system here where there's a gap between the base plate and the sleeper just because of some bulging around the head. So counterboring is really important when you're using things like AS screws, which have a wider shank. S&C, still under early consideration. We've just kick-started some conversations to look at the risks associated with S&C. It is going into the pipeline of projects. We just need to fully evaluate the risk. I know Newark is already in place, but without moving POE, it's still very much in its early and infancy, and so we're working in that space to try and understand what the risk is and where we need to move in that direction. From the perspective of wood, hardwood's not really in our long-term sustainability strategy because it comes from, a long way. The carbon footprint for it is not great, and obviously as a semi-finite resource, not a good place where we want to be. So some of the transfer to either 100% composite and moving fully away from the hardwood is the direction of travel that we want to go to. It's a relatively minimal cost, although we recognise that HDPs and other sleepers are more expensive, and there's a business case and a justification to going into the back of that. And there's some information on some of the effective savings that you could see in that. And at the moment, we've talked a lot about RBM and RCM. We can't factor those potential savings at the moment in, say, 001, where you could, in theory, extend your maintenance inspections with a longer lasting sleeper. We can't see those benefits yet. So it will be a long-term phase out. There's no immediate plan to do this. We're still in early conversations about how that happens. But that is going to be the long-term trajectory for where we go to. At the moment, obviously, we're focusing on the plain line elements, and longitudinal bearers and S&C will factor into that, but we just need to understand the plain line element first, as that's our sort of majority volume. In terms of other projects that are going on in the background, Nick Matthews is kindly hosting or looking after this project on integrated composite sleepers. This is basically looking at alternatives that we can use that maybe replicate things like the existing G44 concretes, where we can have fast clips in place, we can have high lateral resistance. Basically, the ideal sleeper that we can have, can we get sleepers to manufacture exactly what we want from a sleeper instead of just automatically applying the sort of rectangular sleeper that we sort of know as we see it today, but maybe there's other benefits we can reap from the sleeper that we don't currently see. Another project that Darren has been looking after for us is lateral resistance testing of sleepers. This is really going back to that same conversation. I guess it ties into Brian's work on buckling as well, is understanding actually can we improve the lateral resistance of our sleepers or better understand the lateral resistance of our sleepers, and in some cases enhance that to maybe mitigate the need for lateral and resistance plates or other mitigations that we use to increase that lateral stability without having to do such an intense job, either labour intensive or additional cost in terms of implementing alternative devices. So a whole load of testing with different sleeper types, with USPs and without USPs, because there's been some notable examples where USPs increase the lateral resistance. And what we're trying to do is comparatively compare all of those different designs and assess which one's better than each. Might not be able to put a single value against things, but give us a better understanding of actually what the opportunity is in terms of improving lateral resistance from one component to another. Outside of composites, we have concrete. I mentioned we've been doing a lot of work to reduce the carbon in concrete as it is, the majority of that in the cement. So at the moment we're looking at low cement sleepers, which is looking to reduce the carbon content, the embodied carbon, by approximately 50% per sleeper. The CEM 2 mixed designs have just been approved, the CEM 3 ones, so looking at even lower, are still in the pipeline, but we're working towards approval of that. And the use of recycled aggregate in the concrete is still being evaluated. A proven sleeper type is getting there, but we're not quite ready or to do any kind of approvals on that. But that's another thing, bringing the carbon content down again. Another thing that's got a lot of engineers quite excited is the sort of what's being seen as a bit of a silver bullet at the moment, sulfur sleepers. So this is replacing effectively the cement in concrete with sulfur. And what that does is it reduces the carbon content, but it also makes it circular. You can effectively melt the sleeper, remold it and reform it using either existing steels or replacement steels. And that's sort of seen as like a fully circular alternative to the current concrete, which is not so easy to melt down, crush, regurgitate and turn into another sleeper. So we're going through that process at the moment. Literally last week, we approved the first of type. So there'll be 10 sleepers that are being manufactured, and I've got some conversations to have with my route colleagues very soon to organise the trials for those locations. But other than, that is the example in the bottom picture there. It looks exactly like a current concrete sleeper, so it's a lot easier to recognise and understand for all intents and purposes. You can treat it like a concrete, so it's less of a step change than we'd see for, say, composites. There's some value examples in here. I won't go into all of the details in here, but you can see how, from a carbon perspective, and if you can incorporate a cost against carbon, how the total value of the sleeper is significantly greater than the cement alternatives. And these slides will obviously be shared, so if you want to digest some of that detail and understand where the existing supplier is coming from in terms of how that benefit can be reached, you can find that in the slide. And then talking about future designs as well. So we have our existing standards, which are very focused on materials. So 021, 029, 030 and 039, which is effectively the steel, wood, concrete and composite sleepers, are all very definitive in terms of what we do and don't accept from a material property. They're very well defined, which is a good thing from a perspective of achieving a specific requirement. But having something that's a bit more overarching would be useful to understand actually what do we want out of a sleeper, rather than just saying exactly what we want out of a particular material. Are we stifling innovation by not having opportunity to just say this is what a sleeper needs to look like and do, and outside of that, be creative? So Darren, again, has been working on that for us, and that's currently in development, I think in final stages. And that will look to sort of work alongside the 2102 standard in terms of design and construction, and just be a bit more loose to allow innovation in the sleeper world rather than just being so fixed in what we currently have. There's a whole load of additional work streams. So as part of the sleeper strategy group that we do, we've been looking at a whole load of work streams, and you can go into detail in these, but it's looking at all of the angles of where we can improve sleepers. So that includes the whole life cost, the policy, some sleeper selection criteria, where we can reduce carbon more, and actually how we can improve the supply chain as well. We can break those down, so there's some, well, the majority led by technical authority and SCO, but we also have engagement with our routes and regions in terms of what that looks like and what do they want from our sleeper strategy. And in terms of sleeper selection model, this is something, again, Darren has been working very hard on, but across the board we're trying to push something of the buzzword decision support tool in helping understand exactly what you want and what you can get out of a sleeper. So some of these items have sort of been taken out in terms of like whole life costs and the unit rates just for this presentation, but those eventually will be in there with the life expectancies, and hopefully we'll get some better understandings of lateral resistance performance and, say, ballast geometry degradation rates, which will help people make better decisions for their route or region and their location specifically as to which component or property they should use. So I think lastly, I was just going to do a poll. Liam, if you'd like to do the honours. And my poll, rather than asking you a question and getting us to give an answer, is maybe some feedback on sleeper strategy in general, I guess, and where you think we could be sharing more information with you. So based on your knowledge and some of the presentation that I've given today, what would you like more information of, so we can basically cascade more information in these areas and make sure you've got the information that you need relative to what we're doing. So we've got composite sleepers, composites and S&C, low carbon and sulfur, concrete, phase out of hardwood, and I think somewhere down there is, what about steel? That'll do. Perfect. So there's no right or wrong answer to that one. That's just more informative for me, so I can take some stuff away and I can hopefully prepare a little bit more information for you guys and girls, just to make sure we're doing the right thing by you in terms of the composites and make sure you've got the right information. So other than that, that's a whistle-stop tour. I won't harp on because there's probably trains to catch, but thank you very much.